Hello and welcome to the discussion of Lab 1, which is in week 2. This is an online, so in week 2 we're doing Lab 1 online. And what I want to do essentially for Lab 1 is I'm going to open my Blackboard, I'm going to show you Lab 1, I'm going to walk you through it, and I'm going to talk about the different valves and actuators and stuff and what they actually do and what the whole purpose and function is. I mean, we are studying pneumatics, so pneumatics must have some components, whatever they do. I would have loved to be able to teach you guys valves on Monday so we could be prepared for this, but I couldn't go to the Monday class. But essentially, the valves are really simple things. I mean, if I were to miss one lecture, that one would have been good. Thursday, tomorrow, which I have off all day, I'm going to be doing a video, and I'm just going to fly through these things. It'll be like a half-hour video. It'll be pretty quick, so I need you guys to watch that. And then there's actually homework that you need to do, and you can submit that. But that will help you. Doing that work will also help you kind of do this lab later after this class is done, where you can leave and then you can kind of tackle this lab on Automation Studio. So what I'm going to do is I'm going to go over here and I'm going to share my screen, and then we will start Lab 1. Okay, here we go. I'm going to sip my tea first. Yeah, I'm still tired, but I'm getting better, but I'm like a zombie. Okay, let's go. Wait, here is where to go? Where to go? All right, there we go. All right. Hello, welcome. So what's going on is that I need to tell you guys, we need to go through this PowerPoint, right? This PowerPoint here was an introduction to cylinders and valves. Okay, so this is kind of a supplementary kind of PowerPoint to what we discussed in what we would have discussed in the lecture, which I will discuss in a video tomorrow. But I'm just going to open this up and let's just go through this, okay? So essentially what's going on here is this is a lab lecture 1, introduction to cylinders and valves, and here we go. Essentially, now pneumatic valves, okay, so essentially what's going on is they have this kind of terminology that's open and closed, just like a switch is either open and closed, okay? So pneumatic valves work very much like electrical switch, and a relay contacts, it's just an electrical contact can either, just like an electrical contact, they can either be open or closed. Okay, so as you know, when an electrical switch closes, it allows electrical current to pass through it, and its contacts, and it contacts when the switch opens and the current stops. Dude, I can't even talk properly. I'm so tired. But what I'm saying here is that valves and switches are opposite. Now watch this. Just let me say this. When a switch is open, the current cannot flow through. When a switch is closed, the current flows through. But valves are different. Well, think about it. If you close a valve, does that mean that the flow can go through it, that the liquid and or the air can flow through it? No, it's closed. So what I'm saying is you've got to get used to the terminology that it's backwards. So it's all backwards, and let's move forward to this. Okay, so opposite technology, okay? When a switch closes, it allows flow, and when it opens, it stops, okay? That's for electricity. But for a pneumatic valve, it works the same way as electrical switch, except the terminology is opposite. Okay, when a valve becomes open, it allows air to flow through it. When a valve becomes closed, it stops the air. I mean, it just makes sense. You just have to get used to using the terminology. A closed valve means that it doesn't allow flow. A closed switch allows flow. So it's kind of just opposite. Now, as long as you're saying the word valve, I think you got things covered. Okay, so now we also, just like we have in switches, we have what's called normal states. But as I taught you guys in 110, anything with a spring on it has a normal state. Anything with a spring on it has a normal state, okay? So some valves, not all valves, some valves have springs in them, just like switches. Some switches have springs in them, and some switches don't have springs in them. Cool. So essentially, if a valve has a spring in it, it has a normal state. So for instance, a push-button valve can be normally closed, no flow, or normally open, allowing flow. Okay, so we're going to take a look at how these valves work, but we'll just continue here. If it's a normally closed valve, then when it's not activated or it's not pushed, it will not allow air to flow through it because it's normally closed. Okay, once it's activated, it becomes open and the air will flow through it. Now this is what's going on here. Let's just kind of take a look at this. This is the symbol for a valve. We're going to get into these different kinds of configurations. What I need you guys to do, this is kind of the first time I'm walking you through that, so just kind of really pay attention for a second here. This is one side of the configuration right here. So this square here indicates one type of action or one type of mode that this valve can be in. The other type of mode this valve can be in is this one. This lower one is the normal state of this valve because there's a spring on it. When I press the button, what's going to happen is this configuration becomes the active configuration. Now watch this. Imagine that you hooked up pressurized air to port number 1, this little line coming out of here. You hooked up pressurized air there. Pressurized air would come in and would get blocked by this T. It would go nowhere. Now, it seems as though there's this connection here with port 2 that goes over to port 3, and I guess it looks like the air can flow here. So if I were to have pressurized air here, it would flow this way and it would come out port 3. Okay, well that's fine. Let's just move forward. If I were to press this button down, what's going to happen is that if there's pressurized air in port 1, like there is over here, this port 1 and this port 1 are the same port. This port 3 and this port 3 are the same, and this port 2 and this port 2 are the same, except this configuration is now connected to these 3 ports. This configuration here is connected to these 3 ports. When I press this button, it changes this configuration to the one above it. The one above it comes down. Now, pressurized air can go from port 1 out to port 2. And if there is any pressurized air at port 3, it gets blocked. Now, you may be wondering why there are 3 ports. Like, wait a second. When we're talking about, like, this is actually a basic valve. This is really basic valve. I mean, they get even more basic than this, but this is a pretty standard basic valve. A standard basic switch has 2 contacts. It's got like one contact and the other. The current either goes through one way or the other. I mean, it's bidirectional. There's no polarity on a switch. Well, it happens to be that the standard, like, basic valve actually has 3 ports. And you will understand why it has 3 ports, pardon me, once you watch my lecture that I'm going to do on Thursday. So this is the concept of a valve. And you can see in this case, it's normally closed because in its normal state, port 1 is blocked. Cool. So now this is also normal states. This is another kind of valve. And this valve has like 5 ports. Well, that's crazy. Why does it have 5 ports? Well, again, you'll understand the depth of why 5 ports exist when you watch my lecture. But you're also going to find that out today as you see me build an automation studio and run it. Okay, here we go. So the normally terminology is only used, okay, where there are valves with 2 ports, okay, 3 to 2 ports, like this, 3 to 2 ports, because essentially we're really interested in port 1 and port 2. That's where the pressurized air flows through. The function of this port 3 is actually just to exhaust any kind of pressurized air that's kind of left over. So really, even though this has 3 ports, the 3rd port is kind of almost like a backup, kind of like a backup venting after you've activated the valve. So essentially, this is like a 2-port valve, but there's this extra kind of 3rd port for exhaust just to get rid of extra pressure. So we can say that it has a normal state. In this case, this normal state is closed or non-passing. Another term I'm throwing at you. You will hear me intermittently say closed, non-passing, open, passing. So in this case, this valve is normally closed, which is normally non-passing. And if I press it, the valve port 1 to 3 becomes passing or open. Down here, the thing is, because we've got all of these ports, there's no normal state specifically. There's no normal state because there aren't 2 ports that we're talking about, right? In this valve over here, we're talking about port 1 and 2, the main focus. Over here, there are actually 4 ports that have a main focus. There's port 1, 3 ports. There's port 1 and 2 and 1 and 4. Ports 5 and port 3 are, again, actually just exhaust ports. They're to get rid of that extra pressure, okay? So what's going on here is this is a 5-port valve. Now, it has a spring on it, so it has a normal condition, but it's not either normally open or normally closed, normally passing or normally non-passing, because actually port 1 and 2 in this case are normally passing or normally open. Port 4 and 5 in this state are actually passing or normally open, and port 3 is blocked. Over here in this normal state, port 1 and 2 are passing. But ultimately, because they're actually really only 2 ports that really matter in here, we can say that it is either normally closed or normally open because we're talking about port 1 and port 2 generally only. In this case, we've actually got 3 ports that we're talking about. This port and that port are just exhausts. So just to kind of let you know what's going on there, let's move on a little bit. That's a symbol for an air supply, so I can put this symbol here to air supply. We're starting to see this valve open up a little bit. This guy is called a pilot, and that is a pilot. By the way, you can picture the fact that I can activate this valve by physically pushing this. Okay, well, over here, this is a lever. I can physically push this lever to activate this valve. And of course, there's a physical push from the spring, pardon me, to push it back the other way. But what I'm talking about here is we have another option to activate this valve, and it's called a pilot valve. Sorry, a pilot port or a pilot activation. This is a pilot activation, and that's a symbol for a pilot activation. Pilot activation is actually pretty cool. It's just a burst of air. So in this case, I'm physically with my arm, my hand, moving this lever, or I'm physically pushing this button. But in this case, dude, I can just put a burst of air in here and change the state of this valve. Now, just like we had with the other valve, with the first valve, we have 2 states. We have this state here or this state. So either all of these ports, port 1, 2, 3, 4, and 5, are connected to this configuration, or they're connected to this configuration. It all depends on whether I put a burst of air here or a burst of air here. Valves are really cool. So this is just a schematic of the logical connections of a valve. It's not actually what a valve looks like inside. Let's move on with this. Here we go in an application, and this is where we're going to see these exhaust ports in action and see that they're important. Now, over here, I know that the normal state of this valve is this particular configuration. That's its normal state, okay? Now, what I'm going to do is I am going to release this button. I'm going to push this button up. If there is pressurized air in this pilot, it can vent. Now, this spring is going to allow the air being vented in here. There's no more pressurized air in this pilot. It's going to allow this spring to push this configuration back this way. It's going to allow this spring to push this configuration back this way, and now this configuration will be active. Now watch, see what happens. If I have pressurized air in here, it's going to go up here into port 2. It's going to go up here, it's going to go up here, and it's going to make this cylinder retract. Yeah, this is a symbol for a pneumatic cylinder. It's going to make the cylinder retract. Air in here is going to flow out of here. It's going to come down here, and it's going to go out port 5. This is a symbol for an exhaust. Cool. So now let's see what happens when I do the other thing the other way around. I'm going to press this button. When I press this button, this valve goes down. Now, the air goes from port 1 into port 2. It goes into the pilot. It switches the configuration of this valve. Before, it was here. Before, it was the spring was the active state. Over here, this valve was moved over here. This configuration is active. And watch this. This makes a lot of sense. The pressurized air goes up here. It goes up here. It goes up here. It goes up here. And it's going to make this cylinder go forward. As it's going forward, air has to leave. It goes through the valve and it comes out here. Dude, this is awesome. Now, when I release this, the lower valve becomes, the configuration of the lower valve happens. The spring pushes this whole piece, this configuration over, because there's a ventilation from this air. See, this was pressurized air in here. The darker color means pressurized air. because there was pressurized air in here, but I'm giving it a place to leave and it exhausts out here, that allows this spring to push this, what we call a spool inside the valve, but it actually pushes the whole valve configuration over. And now this is connected here, and then this cylinder can retract. So I'm just telling you how important it is to be able to vent this air out of here. Now, the exhaust itself comes from this. When I'm putting pressurized air in here, it creates a force and a motion this way. The air over here is going to be a lower pressure because it's seeing atmosphere. It's actually connected to just the atmosphere. So it's going to flow out here and it's going to exhaust out here. However you look at it, there's always going to be pressurized air stuck somewhere in the system that needs to be vented. So here we have pressurized air stuck in the cylinder, it needs to be vented. Here I have pressurized air inside my pilot, and in this case it has to be vented. It's absolutely crucial that we understand that pneumatic valves always have that third extra exhaust port, or in this case, this has two exhaust ports. Always has an exhaust port because no matter how you look at it, there's always going to be pressurized air stuck in a system somewhere. Now, I just told you guys that there's a push button, I can change the state of the valve. There's a lever that I can change the state of the valve. And there's something called a pilot that can change the state of the valve. Well, there's also a roller, and this guy is a limit valve. You guys know limit switches very well. We talked about limit switches. To some degree, we talked about limit switches in 110. This is called a limit valve. And what's going on here, limit valve is going to have a spring in it for sure. All limit valves have springs in them because one thing that activates them is a cylinder extending and hitting its limit. And when the cylinder goes away, they go back to their normal state. Now, in this case, this is a normally non-passing, or I can call it a normally closed limit valve. And the reason I know that is because when I zoom in here, look at this, port 1, where I do have pressurized air, remember that's the symbol for pressurized air, port 1 is blocked. Port 3 is connected to exhaust, so if there is any pressurized air stuck in port 2, it can vent out here. This guy is in its normal state. This is a normally closed valve, or again, I call it a normally non-passing valve. There you go. So limit valves, okay, what's going to happen is they've got exhaust ports too, and they are polarity sensitive. When you get into the lab, you will notice that actually you have to put pressurized air into one, and then out of two, you have to go, the signal from here has to go somewhere, usually to a valve that actually then moves a cylinder called a DCV. And then this port here, number 3, is always the exhaust. So you can kind of hook this up backwards, but it doesn't really work. It actually does work, but it only works half the time. And you'll see that in action. I want you guys to hook up your limit valves backwards when you're in the lab and you realize, oh, they have polarity. They're polarity sensitive. If you hook them up backwards, they'll kind of work, but they'll vent air into atmosphere half of the time. So there you go. These things are used to generate some kind of signal that indicates a pneumatic cylinder the state of the pneumatic cylinder. It's either all the way extended or all the way retracted. And by the way, if we want it, dude, I didn't know I was not here. How long was I gone for? How long was I gone for? 3 to 4 minutes? About 10 minutes? Oh my gosh, where did I leave off? Like 10 minutes? Oh my gosh, dude. I was just like, I thought I was recording the whole way. I thought I was like, yeah, this slide and this valve and this exhaust valve, and I was talking about the PowerPoint. Did you guys even get to the point where I was actually doing the PowerPoint? Everything's good. Okay, slide 10. Okay, good. Slide 10. Essentially, we got a limit valve here, and the limit valve indicates that a cylinder has either reached its limit extension or retraction. It hits this roller, it activates this valve. The valve changes state and either allows air to pass through or blocks, because I can get a normally open limit valve where when I activate it, it becomes closed. Cool. So essentially, now this is a DCV, okay? Directional control valve. Directional control valve, DCV, very common word. We're going to use the word DCV quite a bit. There are two configurations in this DCV. It's either this configuration that's active or that configuration that's active. Now, we've got these two things on either side, pilots. In this case, I've got two pilots that are activating this valve. Again, I'm putting a burst of pressurized air in here, and then I make this active. If I remove that pressurized air, and I put a burst of pressurized air in here, it moves it over to here, and this valve, this side of the valve is now connected to ports 4, 2, 5, 1, and 3, and it's making that active. Now, let's see this in application. Essentially, what's going on here is that these little triangles are pilot valves, and I explained what's going on. Let's actually see it in actual action here. So watch this. This is really cool. I can actually use low flow and low pressure, just like a relay. I can this valve here, this push button valve. This could be a limit valve, by the way. This could be a limit valve. But in this case, I got a push button valve. I have maybe 10 PSI in here, and I'm going to burst air into here. It's going to activate this pilot. It's going to physically change the configuration of the valve so that this configuration is the active one. It is the one connected to port 4, 2, 5, 1, and 3. And then what's happening is that now the air can flow through here and make this cylinder extend. When it extends, the air from here is going to need to get out. It's going to exhaust through here. Like a previous slide, I just want to make sure. Yeah, like a previous slide, there's always going to be air that needs to exhaust somewhere. In this case, it's the air that is stuck on this side of the cylinder. It's got to leave, goes through the valve, and it comes out. Now, I could hook up 100 PSI here, which generates a tremendous amount of force extending this cylinder, and in retraction, a tremendous amount of force. But I'm actually using, say, 10 PSI to control it. Pretty cool. So pilot-operated valves are really cool. Now, in this case, I just wanted to say that this is a DCV. It's just a valve. And we saw earlier that we can have a push button that changes the state of a valve. We can also have a lever that changes the state of a valve. We can also have a spring that changes the state of the valve. And we can have a pilot that changes the state of the valve. And also, we can have a roller that changes the state of the valve. And by the way, there are many other things that we could put on these valves to change their state or to activate them. So what I'm saying here is that you can go get a DCV, a directional control valve, with a push button on one side and a pilot on the other. With a push button on one side and a push button on the other. With a lever on one side and a lever on the other. With a lever on one side and a pilot on the other. With a lever on one side and a spring on the other. With a push button on one side and a spring on the other. Like, the configuration goes on and on and on and on and on and on and on. And I think you get it. Can I repeat what a pilot is? Absolutely. Essentially, what's going on is that a pilot, okay, let's just go back over to here. I just go over here to the pilot. A pilot is actually a little tiny kind of, it's almost a little cylinder inside the valve that when I put pressurized air in here, it physically moves the valve. In this case, I need a force. I need a physical force to move this. In this case, this roller gets pushed by something hitting it, like a cylinder, and it physically makes the valve move. So I need a force. In this case, I've got a push button. I'm physically pushing the push button, and it moves the state of the valve. What's going on in a pilot is that I just put a little tiny pressurized air in here, and there's a little tiny cylinder in here, and it physically pushes it around, Can be electrical signal? The answer to that is yes and no. And I'm going to tell you this. It's pretty cool. It's a really good step to go to. Can it be electrical signal? Yes. And we do that with what's called a solenoid. Yeah, we talked about solenoids in ATMN 110. We didn't unpack them a lot, but you did hear the word drain solenoid many times in the labs. A drain solenoid is essentially, it's a valve, right? And it's got some kind of solenoid on it, and you energize the solenoid, and it physically creates a force, because solenoids create force through electromagnets, physically creates a force, and it pulls the valve. It actually changes the state of the valve. Or in some cases, it pushes. And generally, for the solenoids, inside valves, it's pushing. So it's actually pushing as opposed to a push button or a lever or a pilot, a burst of air. It's actually an electrical impulse. That's when we get into electro-pneumatics, and we will definitely get into electro-pneumatics like big time. Okay, and then we'll start to do ladder logic as well. So going back over here, sharing the screen, give me a sec. I'm going to jump into lab 1 momentarily. I'm going to finish off this slide. We're getting to lab 1. Here you go. So there you go. That's the last slide in this presentation. I just wanted to say, dude, that's pretty cool. We can use really low pressure, pressurized air that bursts in here and it physically pushes the valve and it changes its state. Now, if we actually talk about lab 1, I've got lab 1 open here. It's called Introduction to Valves and Cylinders. And then all you're going to do is essentially you're going to open Automation Studio up and you're going to get these components and out of the library, okay? So, and you're going to build this. Now, in this case, as I zoom in here, this is a basic cylinder control. We have our DCV right here, directional control valve. And then we've got a push button here, a push button here. We can see there are some symbols here, A+, cylinder A+, A minus. So essentially, cylinder A, the action to make the cylinder extend is called A+. Or when the cylinder is extending, we call that action A+. When the cylinder is retracting, we call that action A-. I think that just makes sense. So I'm going to label this push button A+ because it creates the action A extending. I'm going to label this A-, capital A-, because it creates the extension, it creates the retraction. Here we go. So when I press this button, it changes the state of this as long as there's no pressurized air in here. And guess what? If this is in its normal state, if there is pressurized air in here, it's going to go and it's going to vent out here. So technically, as long as nobody's pressing this button, there's no pressurized. The air in here is just atmosphere. So there's no force pushing this way. If I press this down, pressurized air goes in here. It physically creates a force that pushes this over to here. It changes the state. Now, port 4 will be connected to port 1 because this is going to be connected to port 1 here. This will be connected to port 4. So air will go up here and it will make the cylinder extend. And then any air that's in here will come down here and it will go out from here to here because we can see when this is active, this line here, this arrow will be in between port 2 and port 3 so the air can get out and vice versa, back and forth. So there you go. So that's a DCV. It's a double acting DCV. It's actually, we call it a 5-2 port, and we'll talk about that in lecture for sure because there are 5 ports and there are 2 different actions that can happen. Now, we're going to build this in Automation Studio, and we're also going to be building this in Automation Studio. So this guy is a different kind of cylinder. This cylinder's got a spring in it, so it already automatically has a normal state. It wants to retract. So all we really need to do is either put pressurized air in here to extend it or let the pressurized air go to retract it. So our DCV in this case doesn't need to be a 5-port. The reason we're using a 5-port is because we need to allow the air to exhaust out here. In the case of, let's say during retraction, pressurized air goes in here, any air goes in here, it comes here and it vents from port 4 to port 5. We need to let the air out. In this case, dude, this is actually open to atmosphere. This side of the cylinder is open to atmosphere. Air can sneak in and sneak out, sneak in, sneak out, no problem. So what's going on here, we don't really need this exhaust, but I can press this button, activate this pilot, change the state of this valve so that now port 1 is connected to port 2 because you can see this arrow will go into place here. Air will go up, make the cylinder extend. When I release this, any pressurized air in here will vent out port 3. And this spring will then take over because there's no more force pushing this. Spring will take over and it will connect port 2 to port 3 and any pressurized air in here will and it will vent out and this cylinder then can retract because there's a spring pushing it back. There we go. So how do we know the change of the arrows after we press the button? It's all about looking at what's going on. Now, I know this spring is the one that's active all the time. If I do not press this button, then this configuration is the one that is active because it's beside the spring. So therefore, I can see that port 1 is blocked. Port 2 is connected to port 3 so that if there is pressurized air in here, it can vent to atmosphere or it can exhaust. In this case, if there is no pressurized air here, because I haven't pressed this spring is taking over. Therefore, port 1 is blocked. Port 2 is connected to port 3. So therefore, if there's pressurized air in here, it can vent to atmosphere or exhaust. I think that makes sense. So what we're going to do is we're going to build this in Automation Studio, and we're going to also put in a bill of materials for both circuits. Now, I need you guys to put in your border drawing file. There is a video about how to do that, and you're going to place the drawing around each border, and then you're going to save it as this. Okay, so you put your student name in there. So you're going to lab 1, part A, student number. Actually, this should be part B, student number. So I should edit that. That should say part B, whatever, just copied and pasted. Part B, student number. And again, up here, this is going to be, you're going to save this as part A. Procedure, yeah, save files as lab A part A and then lab A part B, and then submit your Automation Studio drawing for marking. So this thing called paste the drawing border into each circuit, okay, there's a video on how to do that, and I will show you where that is right now. If we go down here, simple borderline, what is that all about? Download your short borderline one? PDF? I don't know. Oh, I think maybe, let me go back over to Labs. Automation Studio Drawing. Okay, hold on a second here. I think maybe Arturo, the other instructor, might have done something here. Yeah, drawing. Okay, so borderline. So essentially, adding a border and a BMO. Dude, just watch this video. When it's 9 minutes long, watch this video and do it. Okay, just don't ask me how. Watch the video. And that's this. Paste the drawing borderline into each circuit. Okay, there you go. So now, as far as this goes, here's the actual circuit itself. So you just download this. I'm going to open it up here. This is a PNG, right? You can open this up in any drawing file, whatever. I open it in Paint. As you know, I do everything in Paint. It's probably just easier to do that. But that's the actual file you need, and you need to follow the instructions in this video to be able to do this. Make your drawing look nice and professional. So now, there you go. I've talked about what we're going to do in this lab, and let's actually go ahead and do the lab. And I have Automation Studio open right here. What I'm going to do is I'm going to go ahead and do this stuff. Now, I'm going to stop for a second and drink some tea. Pardon me. Oh, that's good. Okay, here we go. So what I have is this empty slate here, and I'm going to build an Automation Studio circuit. I'm going to build this first one here, right there, and I will label all of this. I will copy it and paste it, and I'll do some copying and pasting to help you out. Now, what I'm going to do is over here, I'm going to click on Pneumatic. Over here on my left side, Pneumatic. Now, if I go here, there's a kind of a main file or a main area where there are a lot of really common things for pneumatics. If I really wanted to, I could get a little deeper and I could extend this or expand it, and I can go for actuators. Now, I can drop down. They're all, whoa, really? There are all these actuators? Look at a lot of actuators. Yeah, dude, I'm just going to click on the main actuators, and I'm going to go for a single acting cylinder, double acting cylinder. Sweet. I want to use a double acting cylinder, and the reason is because it looks like this is double acting. I can control its extension and retraction. So I want a double acting cylinder. I'm going to grab this and just pull it over here. That's it. We're done. Isn't that nice? I mean, it's not complicated. I'm just going to zoom in. But the way I'm going to zoom in is Control, and then I'm going to just scroll. Pretty standard zoom in. You guys are good with that. So there you go. I have that. Now, I need to put in this DCV. I also need to put in these valves. What I'm going to do is I'm going to put in the valve first, and I'm going to show you something really cool. I need some kind of valve. Now, I'm going to go over. I'm going to close this. Okay? Now, I'm going to go to, say, flow valves. I mean, do I want a flow valve? Actually, the thing is, I don't want a flow valve. I want a directional valve. Now, we did talk about the fact that something that controls a cylinder is called a DCV, but we'll also find many other kinds of valves in here. These valves are, these are kind of two-position valves, and the type of valve I want is a two-position valve. I want one with a spring on one side, and I want one that's normally closed, because when I press it, I want air to go through. So I'm going to go over here, and I'm going to look at some of these. Do I have any of these? I'm going to go for directional valves. I'm just going to click on directional valves. Oh, look, there's one right here. This is exactly what I want. I'm going to grab this. This is a roller. This valve here, this being on a roller, it's actually a limit valve, but I want a push button valve, and this is actually the one I wanted. If I wanted, I could go in here and I could actually configure my own valve through this. But right now, my go-to for this is always just the main thing. If I go to the main area for actuators, I get the basic actuators. If I wanted to go deeper, I could then go for all the different kinds of actuators. Again, when I go for valves, I'm just going to go for the main area of valves, and I'm going to say, this is the valve I want. Now, I'm going to leave that there. I'm going to do this two ways. I need to rotate this. It's not in the right orientation. I'm going to right-click on it, and I'm going to say transformation, and I'm going to rotate right. Okay, I'm going to hit undo. What I'm going to do is I'm going to click on this, and I'm going to hit Control H. Bam. It just flips it for you. Nice and simple. Now, what I want to do is I want to put an air supply on this valve. Okay, I want to put an air supply on that valve. I'm going to go over here to just pure pneumatic. Now, again, I can go deep into these pneumatic things, and I can go look at all of these stuff, all of this stuff. But right now, I'm just going to say, you know what? That's the symbol I want. This is a really common symbol. It's kind of almost one of the most common symbols. It's the one I want. I'm going to bring it, and I'm going to put it in here. Now, I want it to be sideways. I'm going to hit Control H. Or I could go over here, and I could say transformation, and I could say rotate right. Watch this. This is your first connection. I'm going to put this on here and release it, and it's connected. See the red light, the red indication, the red circles go? It's gone. Now, this is where I'm going to bring my DCV in. Okay, again, I'm going to go down to directional valves, and right here, if I just click on the main directional valves, do I have like a basic DCV? Oh, I do. I've got a basic DCV here. Oh, that's the one I want. Externally piloted. Yeah, I want that. I'm going to bring that in here. Like I said, a lot of the times, they're just there. Now, I need another air supply. I'm going to go back to just purely pneumatic. I get two options. One is I could drag this in here, right? And I'm just going to copy. I'm going to undo that. Or I can hit this, and I can say copy, or I can just click on this, Control Copy, Control Paste. Now I got one here. Again, I want this to be rotated. Control H, Control H, Control H, Control H. I've rotated it, and I'm going to connect it in there. Now, I need exhausts here. I'm going to take this and put that there, and I'm going to grab this, and I'm going to put that there. Now, this is where it gets really neat and nice and simple. Copying and pasting is so very important. What I need to do is I need to put port numbers in here, because if you see, all of these have port numbers, and they've got names on them, and there's a cylinder name. Okay, watch this. This is important where we actually take a look at this. This is so easy. I'm going to hit text, and I'm going to make a box, and I'm just going to call this CYL.A, capital A. There you go. Now, this is the problem. This box is sitting on top of this cylinder. It's way too big. I'm going to take my box, and I'm going to put it up here, and I'm going to grab this, and I'm going to shrink my box as small as I can get it. Then I'm going to take this, and then I'm going to move it down there. Nice. Okay, so now I got that. I still have this text tool active. What I want to do is I want to make an A+. Okay, so I'm going to click on this again. I want to make this as small as I want to make it as small as I can without making the actual font go away. I can make it one more smaller. Nice. You know what? I have this. I'm going to put this here. Now I'm going to leave it. I also need to put some numbers. I'm going to go 1. That's all I'm going to do. Now I'm going to take this font, and I'm going to make it smaller. Okay, I want to make this font a little bit smaller. So I've got a couple different options for that. One is I can click on this, and I can go to component properties, and then I can go in here, and I can say text, and I can go to font, and click on my font. Wait a second. Text. Image not available. Oh, composition, rotation, color, visibility, text. There we go. So I am looking at this. Do you know what's interesting? Automation Studio, I just got this as the newest version, newest fanciest version. I don't know how. I just double clicked on that. I don't know how to change the font size. So maybe text, animation, thread, data. I'm just going to go for data. Composition, transition. Free color. Okay, you know what? Forget about that. I am going to go up to here. I'm going to double click this box. Font size, tools, edit home. text. No, text tool. I think this is better because if I do this, if I double click on this, somebody's got something to say. What did you guys know how to do it?
Yeah, sir. It's on the data screen. If you go to font and click the drop-down menu, you can change it.
Okay, cool. One, and then I'm going to double click on it. I'm going to double click on this. Okay, data, font. I click on that. Where do I go?
Mine has a drop-down menu for that. Like where the name is, the big jumbo
Oh, here we
letters.
go. Oh, yeah. There we go. Okay, so let's go for size 8 and see how that works. Now, there you go. That's kind of nice. Thank you. That was perfect. Now, it's cool. I've got this little tiny little font here. And what I'm going to do is I'm going to take this, right? I'm just going to go back to over here. I'm going to click on this. And then what I'm going to do is, wait a second. Yeah, I want to take that and I'm going to take it and I'm going to bring it down here. And I can put it in here. But what I'm going to do right now is I'm going to copy, paste. And then I'm going to say paste. And then I'm going to move this out of the way. And then I'm going to say paste. Oops, daisy. Paste. And then I'm going to put it here and paste. Sorry, paste. There you go. So I've got 1, 2, 3, 4, 5. And what I'm going to do is I'm going to take this and I'm going to put it here. And then I'm going to take this and I'm going to put this here. I'm going to take this and I'm going to put this here. You'll see the method to my madness in a moment. You know what? There used to be a function in Automation Studio. I'm actually going to copy this and paste it again because I need some numbers over here too. That's going to be port 1 for me. And this is, I'm going to paste it again. I'm going to paste it again. And that's going to be port 2. That's going to be port 3. Then I'm going to paste it again. And I'm going to paste it again. And that's going to be my port 2. Okay, good. So now what I'm going to do over here is I'm going to zoom. Wait, I'm going to put this guy. Sorry, I'm going to put this guy over here. There we go. So now I can go in here. I can zoom in here. I'm actually going to move this down a little bit. I'm going to move. Whoa. Uh-oh, my computer almost did some funky something. Oh, I don't know what just happened. Control Z, dude, is so powerful. I love it. There we go. I can move that. Actually, let me try and put that up there. That up there. I think that's going to, it doesn't like it. Escape is a good button as well. Let me just see if I can shrink this a bit. Yeah. That's what I'm looking for. Can I move this around so that it's, how come I could do it? Anyway, whatever. There you go. So there you go. Port 1. I'm going to make this smaller. And I'm going to go here. Awesome. So that's 1. So now I'm going to double click on this guy. Oops, daisy. Shit. It's trying to, there you go. That's what I want to do. I'm going to go, wait. So this is going to be a 2. Actually, it's easier to do this if it's, there we go. 2. So what I'm going to do is I'm going to kind of struggle is the right word, I guess. Just deal with this right now. I'm going to try and, there I go. I got it. Now, if I double click this, if I just single click it, I keep double clicking it.
If you go to text, you can change.
If I go to text, like hit this button.
No. Click on it when you found data.
Oh, then I go over to data. Okay. So you know what? That's fine. I'm going to make this guy go over here. Hold on a second here. I don't want to go through data. I don't want to. Actually, I'm going to move this guy. Hold on. Like, I'm only doing this once, and I'll show you why I can spend the time and effort and energy doing this, and it's actually not going to slow me down because I can have this forever. So this is going to be the first. I'm going to click on. I'm going to escape. I'm going to not escape. I'm going to click on that, and I'm going to click on it one more time, and now it goes to that. Now I'm going to put that as 2, and then click on this. I want to get that, and I'm going to click on it one more time. So this is going to be 1, 2, 3. This is going to be 4. I'm going to click on this. Then I'm going to click on it one more time. That's going to be my 5. Again, I'm going to, you know what? I want this to be out of the way. I don't want that text box to be in there because the text box the text box actually get in the way. You want to make them as small as you possibly can. I'm going to click this again. There, and I've got a 3. Now, I'm going to make this, oops, daisy. I'm going to make this text box as small as I can. There's a method to my madness of going through all of this intricate work. Now, that's really nice. There you go. That looks really, really good. And I've got these guys hooked up here. If I want, I can go over here and all of these look good. Yeah, that looks good. That looks good. Now, what I have is I've got my DCV. By the way, I can get rid of this guy. I can just delete that guy. I just hit the delete key. Now, I can move my cylinder down here, but watch. The cylinder label moved, so I'm going to Control Z. I'm going to grab both of them, and then I'm going to move them down a little bit. I'm going to kind of leave it like that. Now, I need this valve over here. I'm going to draw the whole thing all over again from scratch. Actually, no, I'm not going to do that. That's stupid. I'm going to connect this. I'm going to hit Control Copy, Control Paste. Now, I've got the, well, I'm going to unz. I'm going to disconnect it. I have to grab the whole thing. I have to make sure that I grab the whole thing. So this valve is now connected. Control, Copy, Control, Paste. And now I can put it over here. It's nice to have it. I'm going to use my arrow keys. Oops, daisy. I want this to be at the same height because it looks nice. I'm using my arrow keys to move this over here. Okay, now this is important. We know these things have polarity, right? I'm going to click over here. Now, for some reason, I've connected a line through here. I'm going to connect on this. I'm going to hit delete. I'm going to hit that, and I'm going to hit delete. I don't know what happened there, but essentially, I connected some kind of line. And there's something weird, funky going on there. I don't know what's going on. I'm going to copy this, and I'm going to paste it, and then I'm going to bring it over here. I don't know what just happened, but yeah, that's connected, but that's not. I don't know why that looks like that. That's really weird. I don't know what's going on, but I'm just going to leave it. Oh, I've got a line here. There you go. There you go. That's what's going on. Now, this is my A+. I'm going to click on this once, and then I'm going to click on it again. Now it'll turn into font I can change. I'm going to go to negative. Just one change. All I have done is one change. So I copied this whole thing. I pasted it again. I made one change. And now I can use this exact configuration and this one and this valve for all of my drawings in the future. I'm going to connect this. I'm going to click on this. I'm going to bring it up here and double click there. I'm going to go here. I'm going to bring it up here. And I'm going to double click here. I'm going to bring this guy over here and I'm going to double click. Now this guy has got to come down. Oh, you know what? One thing I forgot to do was put an exhaust in here. I'm going to Control H, rotate it. And I'm going to bring another one in here. Control H, rotate it. So whenever I draw a circuit in the future, I'm going to use this as a template. I'm going to take this, I'm going to come out, I'm going to go down. I'm just clicking over here. I'm going to go click, and I go up here and click, and I go in here, double click. There you go. I now have a working circuit. I can simulate this. I'm going to press this button, and you can see there's actually pressurized air in here making the cylinder retract. If I press this button and hold it, cylinder will extend. Now, if I release it, nothing's going to happen. I released it. There's no pressurized air in here. And this valve, because it doesn't have a spring on it, has not retracted. It's still in the state I left it. The only reason it would possibly change state is if I put air on the other side. Let me just actually move this out of the way a little bit so we can see this in action. Hold on a second here. Let me move this. There, let me move this over here so you guys can see that again. And I do see that somebody has a question. I'm just redoing this so that we can see this in action a little better without overwrapping that. I'm going to press this, and I'm just going to do it momentarily. Press, let go. It physically put air, pressurized air in here. For a second, it was red air. It's pressurized air. It had a force that moved the spool. It moved the configuration of the valve. Now, there's no force to move it back because this valve doesn't have a normal state. The only way that I can make this go back is if I put pressurized air in here and make it go back. There you go. So we have a question. Yeah, it's so cool. Yeah. No question. It's just cool. Now watch this, dude. Watch this. This is great. I'm going to do File, Save As, Project, Save As. And I'm going to go over here and I'm going to go to my drop, wherever. I'm going to go to my courses, 153, labs, and I'm going to go to this. I'm going to say new folder. I'm going to say lab 1 winter 22, and I'm going to go in here and I'm going to save this as lab 1A LARS, and then we're good. So now I could put my student number in there or whatever, but I'm just going to save it. Now watch this. This is really beautiful. You'll love this. Dude, I'm going to use this for all of the circuits I draw in the future. All of them. I'm going to take this. Actually, you have to grab it really big. I have to grab it like really big to be able to get this whole thing. I'm going to move this. I'm going to use my arrow keys, and I'm going to move this over a little bit. And then I'm going to grab this. Watch this. I'm going to make this. I'm going to highlight this line, and I'm going to bring it over here. And there you go. I'm going to do that. So I'm going to sneak it in. Now, I'm going to use that. I can even bring this up a little bit. I'm going to use this exact one for all of my circuits. So I'm going to do this. I'm going to do part B. I'm going to do part B. And I'll do it just in a second. Watch this. This is really cool. Now, I've already saved this. I'm just going to say project, save project, okay? Okay. How do I make those lines? Oh, okay. I will show you how to make the lines. What you do is you just go over here. Whoa, wait a second. Where you just go over here. If I wanted to, like, let's say I'm going to, whatever, I put a cylinder in here. And now I'm going to put an exhaust valve in here, whatever. I want to connect this cylinder to this exhaust valve. I click on here. You see? It clicks into this. It changes state when I do that. I click it once, and now I've got a line that follows me wherever I go. I'm going to go over here. I'm going to click once over here. I'm going to click once here. I'm going to click once here, 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 click, 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 and then double click, and I'm done. Isn't that nice? Cool. So that's how you do that. Okay, cool, guys. So that's what's going on. I'm just going to bring this guy. Pardon me. You know what? Oh, what the freaking, what's going on here? How come? There, that's me. So I'm just going to find that again, Automation Studio. Cool. So now what I'm going to do is I'm going to build the next one. And we know the next one, right, looks like this. Just give me a sec here. The next one looks like this. Oh, it's just dumb, stupid things. There you go. The next one looks like this. It's a little different. I have a different cylinder. I've got the same valve. It's labeled differently. And I have a different valve over here. So you know what? I'm actually going to take this exact thing. Again, I'm going to say, just save. I'm going to make sure I save it. Okay. Now I'm going to go over here and I'm going to say project, save project as, and I'm going to call this part B. Save. I'm going to take this cylinder. I'm going to delete it. I'm going to leave all of those lines exactly where they are. I'm going to go over here to take this cylinder, and I'm going to stick it right here. It's already connected. Now, this line, I don't need this line. It's gone. Now, I'm going to get rid of this because I don't need it either. Because as we can see, I have a different kind of DCV. Okay, so I need this. Now, if I want, I can click on this once, click on it again, and then that will be a B. I'm going to click on this, whoops, to highlight it. I'm going to click over here. I'm going to highlight this. I'm going to click on it once more, and now I'm going to call this a B. Now, all these numbers stay the same, everything except for this valve changes a little bit. You know what I'm going to do? I am actually going to come in here, and I'm going to go over here to my valves, again, directional valves. And I'm going to look at this valve. I'm going to see if I can figure out this valve kind of looks like this. So it's definitely a 3-2. It's got 3 ports here. Now, this says a spring on it. And because it's only 2 ports that pass air, it has a normal state. In this case, it's normally blocking or normally closed or normally non-passing. So I need to find a valve that looks just like this in my database. Okay, I'm going to search for one. I want one with a pilot. Oh, look, there's a pilot. Oh, it's right there. Dude, you mean they're so easy to find? Yep. I'm going to drag this over, and I'm going to put this here. Now, the thing is, dude, I've got all of these numbers here that I've already drawn, and it sucks that I have to redraw them again. Guess what? Delete. Ooh, look at that. I'm going to take this guy and I'm going to sneak him in here. And look, he'll actually connect to those ports. Look at that. I don't need this port. Isn't it nice? Isn't this freaking beautiful? Now, this is going to be, I'm going to zoom in here. By the way, I'm going to connect, I'm going to delete this. And I'm going to connect on here, single click, double click. And then you know what? I probably want to pull this over a bit. You know what? As you can see, I'm not selecting the whole valve. I kind of have to, if I come here, I don't select the whole valve. I have to like grab really big. And then I select the whole valve. And I can move it in with my arrow key. Now over here, I'm gonna put my mouse in the middle. I'm gonna hit the control button and I'm gonna zoom in. Now all I'm gonna do here is I got a couple options. One is I can change. Whoops, it is. Hit escape. I click on this and click on that. It's hard for me to get to that number. Do you see that? But you know what? It's okay. What I'm going to do is I'm going to take this. I'm just going to delete it. I can pull this in anytime I want. I'm going to zoom in here, and I know I'm going to be calling this a 2. So I'm just going to change it to a 2. This guy, I can just delete. I don't need him. How do you zoom in? Okay, so I've mentioned that a few times already, but I'll continue with that. What I do is I put my mouse wherever I want my mouse to be. I want to zoom in over here. I put my mouse here, I hit the control key, and then I use my scroll button on my mouse to zoom in. This is very common practice on many, many drawing programs. Yeah, so you guys know that. Okay, that's fine. So I've done this. Now I know if I look at this, let me just see, what are the port numbers supposed to be again? Oh, that's supposed to be a 1 and that's supposed to be a 3. Okay, I can handle that. I'm going to go over here and I'm going to look up here and I, excuse me, buzz off. Oh, no. Don't you F with me, buddy. Okay, I'm going to go in here. This is supposed to be a 1. I got a couple options. One is I can delete this whole thing and just move this over, which is probably I keep hitting escape. I'm going to move this over here, which is probably a good idea. Now this guy, I can just move him over there. Sweet. Now I'm going to zoom out. I'm going to take this guy. I'm going to drop him right in here and look at that. Oh, that's pretty. Oh, that's nice. Dude, I'm done. I'm going to save. Project. Now I already saved it as, I already saved it as drawing 2, but I'm just going to make sure I did. Yeah, it's as a B. Okay, good. So I'm just going to hit this. I'm going to save because I don't want to lose it because I did all that work. Now, do this. We're done. I mean, it wasn't much work for me to build that second one because I had it already. Oh, look at that, dude. It's already doing its thing. Okay, so now I can let it retract. Oh, look what I did, dude. I put the wrong valve in here. Oh, I made a big mistake. Oh, man, I screwed up completely. Shit, I got to start from scratch. No, you do. Watch this. There are a couple different ways to fix this. One is I can just delete this, and I can easily go get the right valve and drop it in here. Actually, I didn't actually put the wrong valve in here. I just have to understand that the function of this thing, in this case, I've got this case, this air is going to come back here and it's going to pop out of here. Now, for some reason, I've got this thing working backwards. What have I done wrong? Can anyone see what I've done wrong here and why this thing is not working? I'm going to zoom in here. Hold on a second here. Let me just do this. If I simulate this, this is a great test for you guys. If I simulate this, if I press this button, it retracts. Dude, I want this to extend when I press the button. But isn't it the same as this? What have I done wrong? Any thoughts? You guys don't see it? Oh yeah, we got it. Yep. You see that? Now, I wanted to demonstrate that, you know what, when you're copying and pasting everything, you got to make sure that it's okay and you got it right and you do everything else. And you'll find that when you actually run things and if it doesn't work. Essentially what I did was these things are reversed. I just kind of left them where they are. So we can actually hook up a valve backwards and it does the wrong things. I'm actually going to delete this. I'm going to take this and I'm just going to delete it because it's hard. I mean, I could drag this down here and then click on this and then delete this. There's one way to do it. Or I could just say, you know what, I'm just going to delete this. I'm going to go back to pneumatic, and I'm going to pull in this. I'm going to put that there, and I'm going to pull in this, and I'm going to put that there. Nice and simple. Either way you want to do it, doesn't matter. Let's run it again and see what happens. Nice. When I press play, ooh, look at that. Cool. So I want to make sure that you guys kind of just understand how easy it is to draw these things. And it's really about drawing your first one, putting a lot of love into it, shrinking those things down. The reason you shrink the font down is because it gets in the way. Because if you want to click on something to move it or change it or whatever, that particular number or that large font area, even though you've written a word that's this big, but the font is this, the area is like this big, it's going to get in the way when you're trying to select things. Dude, all you have to really do is just do it once. I mean, I didn't have to redo any of the font. I didn't have to put new font in. I didn't have to grab the font tool and use it at all the second time at all. All I had to do was once. All of your drawings from now on for like ever, you can use your first drawing. Put a lot of love into that first drawing. Like put a lot of love into that first drawing. Because as soon as you do that, you'll be like, all of your drawings will be like perfect. And you'll never have to put the font in. All you have to do is sometimes click on it once, wait a second, click on again, almost like when you're changing the name of a file in File Explorer. You know, when you kind of go in the file, you want to change the name of the file. So you go over here and you go to Dropbox and you go to Humber Courses and you go to 153 and you go to Labs, whatever, Lab 1. I want to change the name of this. I click on it once, I wait a second, and then I click on it again. And then I get a change in the name. You do the exact same thing with the font on Automation Studio. You click on it to highlight it, and then you click on it again, and it will highlight, and you can just type. There you go. So I was trying to do that earlier, and it didn't work. I was pretty much just not being patient. So there you go. And then shrink these down to a nice size font and draw this. It's all nice and pretty, and then you can use that exact same drawing all the time. So this is good for Lab 1. Dude, if you guys can pull this off and do this, I mean, what you're going to have to do is you're going to have to download Automation Studio, make sure make sure it's working. Build this circuit, build the first circuit, put a lot of love into your first circuit, label everything nice and pretty and everything like that, and then, pardon me, save it as Lab 1, and then go and then just open Lab 1 again, Lab 1A, save it as Lab B, Lab 1 Part B or B, and then modify it. And then save it, and you're good. So it's just a matter of like changing the valves around and getting rid of some things. So Automation Studio is really nice once you actually set stuff up and get going. Same thing with ladder logic. Actually, by the way, you can design ladder logic in here, and you can do really complicated electropneumatic control with this. And there are pressure sensors and limit valves and limit switches and so many cool things in Automation Studio. Dude, we are just scratching the surface. Okay, there you go. How do I run the circuit? Oh, great question. I will show you how to run the circuit. Application, here we go. I think we'll be good after I do this. I'll let you guys go. Here we go. So I'm going to go over here, and I'm going to simulate this by going up here to my top left corner, and I'm going to press play simulation. There are lots of different ways to simulate it, actually, and we'll get into that in later lectures when we actually need to, and I'll show you how to like diagnose a circuit and watch it in action in slow motion and do some other things. And now I can press it, and as soon as I press my, like obviously it's with my mouse, press it. If I hold the mouse key down, even if I move this around, that stays there. When I release it, it opens up, and then I can hit stop simulation. But if you want, you can click on this, and there are a lot of other simulation functions. But we'll get into that later when we're actually like doing a diagnostic on a circuit and really watching really cool things. I'm looking forward to doing the lab that we're going to do in week 7 when you guys have exams, because that's going to be a completely entirely online lab. So just hold on a second. I think that's good. I am now going to stop recording, and I can say you guys are good, you know what to do, but I'm just going to leave you with this. Download Automation Studio, get it working. If you have a problem, go watch the videos or email me, I guess. But watch those videos in the automation thing, because you should be able to do it. And if you need to get WinZip, dude, it's free. Just go download it. Because when you download the actual Automation Studio, it's in a zip file. So you should be able to unzip files. You should be able to do that really easily, because you need to do that for like life. So download Automation Studio file. draw lab 1A, save it as lab 1A, and then open it up again, and then save it as lab 1B, and then redo it and just change it. And you won't have to redo all the fonts. And then what you need to do is read the lab, and you will see, oh, for submission details, you have to do this. And you'd be like, Lars, what are you talking about? What is that? Well, just go over to Blackboard over here. Wait a second. What am I doing? Where am I going? Yeah, go over to Blackboard over here, and in the Automation Studio videos, wait for it. Here to Automation Studio videos, right? Click, right? You click on this guy, download this guy, and then watch this like 4-minute video or something on how to actually add a border, add it to your file, save your file, and then go to Blackboard and then upload in your week 1, both the Automation Studio files right here. This is for lab 1, and this is lab 2, drawing 1. There you go. Thank you. Oh, you guys didn't see my screen. Just hold on. Let me just show you quickly. Hold on. Cool. Go to Automation Studio. Now, this particular aspect here, paste the drawing border. You need to do that. And how do you do that? Where do you get the drawing border? Dude, go to Blackboard. Go into Labs. Go into Automation Studio videos. This guy, watch this 4-minute video, or 4 or 5 minutes, and then download this guy right here. Okay, make sure you download that guy and have that available. And then what you can do is follow these instructions and get your border, and then put it into your Automation Studio drawing. Save your Automation Studio drawing, and then upload it here. Wait for it. Upload it here in week 1. Down here, click on this guy. And your PRX file here in your PRX. Do not take screenshots of your Automation Studio. Put them in here. I want the actual file. And that's it. Thank you for watching, and look forward to seeing you guys in class next week.